All right. So as Ned said, I'm Matt Rosencrantz. I'm NOAA's lead seasonal hurricane outlook. Um, so we released the outlook at the end of May. We will update it again in August. I'll go through all the specifics of that. Um, Now, again, this is NOAA's hurricane outlook. There are a few other agencies and entities that put out outlooks. So you may see a few different numbers floating around out there that are slightly different than these, but this is NOAA's outlook. Um, just overall, the Atlantic hurricane season starts the 1st of June, so we're 30 days into it now. We have had a few named storms. We've had 3 during the season, and then we've had one back in January that was subtropical storm in nature, but it was unnamed, and it was basically analyzed after a bunch of ship reports and data came in much later. So technically we have had 4 storms this year already, if I'm just to count the year. We had 3 in the season. Again, I said we issued this outlook in May. It's typically the last Thursday of May before Memorial Day. And then we will update this outlook again in August. Right now we're targeting early August. It's usually the second Thursday in August that we target that, because that allows us to get enough data from June and July and process it, and then actually make the outlook and get everything done within those first, 8 to 10 days of August. If you are interested in the East Pacific activity there, they typically do start a little earlier. It's long-term averages. Obviously, this year, the Atlantic got off to a faster start than the East Pacific, although the East Pacific is now catching up. There's likely to have 2 hurricanes in the coming days. Reviewing a bit more climatology, July, so coming up into it, is most of your tropical storm formations actually happen in the Gulf of Mexico and off the east coast of kind of Cape Hatteras area, and then they move from southwest to northeast. There's a small little area down in the Caribbean where there are some storms that form. The 2 that formed this year out in the main development region, Brett and Cindy, very anomalous. Looking into the exact frequency of how often we get main development storms in June, it's very anomalous. It happens during a little bit more during active eras, and I'll get into that. But even June storms typically only happen once every other year. We've had a few recently because we've been in a very active period. But so the July outlook there, or July climatology, sorry. Again, it's mainly the Gulf of Mexico. It's not until you get into August do you really start adding any robust statistics for the deep tropics formations that kind of move from southeast to northwest and bring, and end up being a lot of these stronger storms. That peaks during September. And then with the main development regions, long track storms that have a lot of power with those. And the long tracks, although you do get some short notice storms that can pop up in the Gulf of Mexico. Well, we can see the relative frequencies there. More than half the years do end up with a Gulf of Mexico formation. That orange is starting the 50 years or 50 storms. So that where it goes from green to orange is 50, and those are 100 years in these analyses. So that would be more than 50. Anywhere that's red is greater than 70. So 70% of the years have, if you were to take long-term averages, have tropical storm formations anywhere that are red on these plots. Then as we get back to October, later in the season, you actually do get another kind of local maxima of storms forming towards the Gulf of Mexico, Western Caribbean. The waves that come off of Africa that kind of seed a lot of the activity in August and September kind of shut down in October. And then you start to get more tropical storm formations that happen along frontal boundaries or are kind of more short-lived storms. They have lifespans, 2 to 4 days, and are typically swept from the southwest to the northeast by cold fronts that are coming down as we're transitioning from the warmer months to the cooler months during October. Now, if we look at the same thing for hurricanes, just less frequency in these numbers. So the red areas here are the 50%, and the orange areas here are the 35 to 50%. So when you look at July, it's up to one in every 5 years we get a hurricane in the Gulf of Mexico in July, and then also off the east coast of Florida that could be impacting Florida. Very few hurricanes in July, but then you end up with a major uptick towards August, especially in storms coming from the east. We do get a lot of tropical storms that move in from the east and move across the Bahamas towards Florida, and then kind of gain hurricane strength as they start to interact with the Gulf Stream off the east coast of Florida, and then can really amplify up and develop into hurricanes as they move towards kind of Cape Hatteras. A little bit of formation possibilities in the Gulf of Mexico in a climatological sense, but that really ramps up in September, where you really get your main hurricane threat is really in September for the Gulf of Mexico, for anything that does develop there. And then again in October, you get a real, that it stays in the Gulf of Mexico, but you lose a lot of the deep tropical response typically in October. Now this is looking at 100 years, not any specific year individually. If I were to look at where those hurricanes, tropical storms make landfalls, southwest coast of Florida, Monroe County has the highest frequency of impact strengths in the country. Or impact, they are about every 3 years. This is again about 100 years with the data, and they've had 26 to 32 strikes, so it's every 3 years. There is a landfalling tropical cyclone in Southwest Florida, and then 15 to 16 in 100 years, so once in every 6 years as you go up the coast. Relative minima as you get up towards Apalachicola, and then another kind of the max gets a little bit higher again as you get out towards Pensacola, because you get a lot of those ones coming out of the Gulf, and you also get storms moving from east to west that kind of go across Florida, like a Wilma impact there, then or a Katrina. They can impact southern Florida and then move up and make landfall in other parts of the Gulf. So you can kind of get those, but the ones in the kind of up towards Ocala making landfall towards that region north of Tampa, it's really only the southwest and northeast moving storms that can really impact there. So there's just less of them. And then again, probabilities do decrease slightly as you go north on the Atlantic coast. But I'm going to talk about a little caveat to that for this year and the most recent years. So now I want to take a little bit of time and look at, we looked at formation regions. Now I'm going to look at how much energy is actually dissipated in these storms throughout the year and how we look at these in multi-year periods. We kind of, at NOAA, we categorize these into activity eras. From 1950 to 1971 was a high activity era. We had a lot of storms. You had a lot of storms with long tracks, dissipating a lot of energy, and this is our accumulated energy index that we calculate every year. 1971 to 1994, we had a relative lull in activity, where most of the years you can see on there were below normal threshold, which is the orange bar on this chart. The black bar on this chart is our threshold for an above normal season, and the red bar is the threshold for a hyperactive season. That's defined in the atmospheric science literature as 165% of normal. So we had that high activity era 51 in 1970, a low activity era 71-94, and then the high activity era 1995 and onwards. Those activity eras are very much related to the sea surface temperatures. When they are warmer in the northern Atlantic, we typically are in a high activity era period. When those winds are more favorable, the trade winds are a bit lower in the Atlantic. When the West African monsoon is a bit stronger, and when the wind shear in the Atlantic is a bit lower, all of those things are associated with high activity eras. They all go together because the sea surface temperatures can end up changing the atmospheric circulations to be more favorable for tropical cyclones. So there's a bit of a feedback cycle there that happens. So the And these periods last anywhere from 25 to 40 years. Right now, we've been in a high activity era for 28 years, and we don't see any signs of that changing. Most of the predictive models that look at this give us anywhere from 12 to 24 months where you would start to see the sea surface temperatures in the Atlantic changing and starting to get closer to normal. But this year, the sea surface temperatures across the Northern Atlantic are very warm. And so we're not seeing any change in them towards a near normal. So we are not likely to, we're not likely to flip into another activity era this year, or even next year, because the next cycle would be longer. That change would take longer than, the next 11 months. Again, they take typically 12 to 24 months, sometimes a little bit longer. The reason we really like to look at these activity eras, not only to make these predictions, but for preparedness, because the high activity eras have the largest increase in hurricane landfalls along the Atlantic coast. So your real difference in your storm frequencies happen over the main development region of the Atlantic, and those would make landfall, and along the east coast of the Atlantic coast of the U.S. Most of those landfalls along the east coast of the U.S. are between Cape Hatteras and Florida, and southern Florida. So you would see more impact for storms moving into and potentially impacting the east coast of Florida during a high activity era. We do also see a doubling of the seasons with multiple hurricane landfalls. So that means FEMA would be responding to multiple disasters should two hurricanes make landfall in different places. As you know, the early 2000s, there were some years where we had multiple storms impact the west coast of Florida. Then it got kind of quiet for a couple of years, and then we've had a lot more landfalls with high-end category, 4 and 5 storms making landfall in Florida. Haven't had as back-to-back landfalls in the same location in Florida much recently. Louisiana had a lot of that in 2020. The 2 storms kind of right into the, the heel of Louisiana. So while they had tarps over buildings, they had another hurricane come through. So it can be especially devastating, especially difficult on the emergency response side during these high activity eras. So given that we are in a high activity era, that did inform our outlook here. We are also in an El Nino this year, which would kind of potentially counteract the high activity era. So that mitigated a bit of our outlook. The outlook for this year is for a 40% chance of a near normal season, which normal is 14 named storms. So we should be 14 plus or minus a couple of storms, according to this outlook. And that gave us 12 to 17 named storms. Now that's actually a slight shift. Potential for more activity, right? That's 14 is the normal. 17, we have 3 on that side, only 2 towards the lower side, going down to 12 for the bottom end of the range. And that's because of the high activity and how warm the sea surface temperatures are in the Atlantic. We wanted to kind of hedge towards that a little bit in the numbers. And we'll see if that continues during June and July, and where we take the outlook in August. We did 5 to 9 hurricanes this year. Normal is 7, so that's kind of spot on. Normal for major hurricanes is 3. We are on the low end of that. Major hurricanes contribute most to the ACE and to the total energy dissipation. So that is one thing that we did notice in the statistics, is that when we do have, even if we have a warm sea surface temperature Atlantic, if we have an El Nino, you increase your wind shear, and that can really reduce your major hurricanes in the Atlantic, and that can also reduce your total seasonal energy. So that's why our seasonal energy does have a bit of a lower end to it. Really, it's reflective of the major hurricanes, not the number of named storms. And again, we have had four storms as of 6/26, and I could say that as of 6/30 as well. So in a bit more tabular format here, again, 40% chance for a near normal season, 12 to 17 named storms. All Also on this chart here is the outlook from May 2022 and August 2022. The outlook verified the total number of named storms and the total number of hurricanes, as we had 14 named storms and 8 hurricanes last year. We only had 2 major hurricanes last year. Our outlook range started at 3. So technically we did not verify during that in that category, nor did we verify the accumulated cyclone energy, because we didn't have enough major hurricanes to give us that total amount of energy. We're looking into why that July through August period of 2022 was so quiet. It does typically produce 2 or 3 more named storms, 1 to 2 hurricanes, and 1 major hurricane during that time period over the entire Atlantic basin. So we're looking into why that was so quiet. And then can we predict that in future years? Is that something that's predictable? So that's where the science is kind of taking us, and reviewing 2022 and incorporating that into our predictions for the next year. So again, what led us to this outlook? I've already mentioned that we are in an El Nino. We can see in the upper left here, the El Nino, the warm sea surface temperatures across the Pacific, right along the equator, and that will change wind patterns on the entire globe. So we are looking for the impacts of that to start showing themselves across more of the globe. We can change the sea surface temperatures, but that takes a little while to change the atmospheric circulation. It's kind of like if you had a pot of water, and you're just boiling that pot of water with a single flame. Well, El Nino is moving that flame underneath a different part of the ocean, or underneath a different part. So you'd have to wait for your bubbles to come up in a new part of that pot. El Nino, that sea surface temperature change is like moving that candle and moving that flame underneath a pot. You have to wait for the bubbles to come in a new place and change the top of how the water is kind of responding to that. But we are seeing some of those changes. You can see in the middle plot in the bottom, we are starting to actually see some flow out of the central Pacific, turning up into the jet stream that will then carry some of that moisture across the western US and creating a subtropical jet there. We are also starting to see some outflow a little bit into the southern hemisphere as well, with the southern hemisphere anticyclone. So we're starting to see the responses as the month of June went on. So that's why we did declare the start of El Nino in June. The sea surface temperature anomalies in the Nino 3-4 region, which is what we monitor, which is out in the Pacific from 120 degrees west to 140, or to 170 west, sorry, so 120 to 170. That was a 1.0. Our threshold is a 0.5 degrees centigrade. So if we look on the chart on the right here, all the Nino regions that we look at, that's the Nino 3-4 region kind of straddles the Nino 3 and the Nino 4 region. That's why it's called the Nino 3.4 region. They're all above normal. So we're not really looking at anything that could disrupt the development of this El Nino. It's robust enough from spatially, it's robust enough at depth in the Pacific. So we're not looking for anything that would disrupt this at all. The wind patterns are looking favorable. Even the wind patterns for the next 2 weeks or the next 3 weeks are looking favorable that this El Nino will not only continue, but potentially strengthen. There is a link in the bottom here if you want the latest on El Nino. That is updated every month, second Thursday of the month. Why does El Nino matter for us? It controls about 33 to 38% of any of the changes in tropical cyclone activity. And it typically does it via changing of the wind shear. This is a wind profile. So if we're looking at the bottom of this plot, this would be the ground. The top of the plot would be the tropopause, about 16 kilometers up in the atmosphere. So quite, about 8 to 10 miles up, about 10 miles up actually. So what we're looking at here is also El Nino will cause higher winds in the tropopause, up near the tropopause, and also a bit higher winds in the Western Caribbean. That increases the wind shear, and that tears apart some thunderstorms, so they cannot coalesce into a tropical storm. La Nina, on the other hand, which had the past couple of years, would do the opposite, and that would favor where it would reduce the wind shear, reduce the difference in wind from the low levels to the upper levels, and that would favor more storms. So what we're seeing in the outlook and the conditions this year, we have El Nino that would reduce tropical cyclone activity, but we also have these really warm sea surface temperatures. We're seeing low trade winds. We're seeing a strong West African monsoon. So we're kind of seeing competing conditions. And that's why our outlook ended up being straddling the near normal outlook, because we have one that's saying you should be below, one that's saying you should be above. And between the two of those factors, they actually control about 80% of all the variance that we see in tropical cyclone activity. So the 80% of our factors are going opposite. So we end up with just being in the middle for now until we see what happens in June and July. So are we likely to stay in this El Nino as we get into the August, September, October period? And yes, we are. Between the models that we look at, the expert analysis, that we have a 95% chance of this El Nino having staying power through the August and September and October period, when 90% of your tropical cyclone activity in the Atlantic happens. So again, 90% of your activity in the Atlantic happens August, September, October. 70% of your tropical activity in the Atlantic happens after August 20th. So the Atlantic has a very peaked and strongly peaked activity, kind of second half of August through October. Models that we look at to forecast El Nino, that's kind of a summary graphic on the left, but every one of those lines actually has 20 or 30 members that go into those lines. We have about 115 model runs that we run, simulations of the planet, for the left-hand side. And the right-hand side is a statistical consolidation based on the historical skill of many of those models on the left. And the blue, I guess the turquoise plot here is if we took the historical skill of all these models on the left and then said, okay, let's weight them all, what would our most likely outcome be? And August, September, October, we are very likely to be in El Nino, and there's even some possibility of being in a strong El Nino state. There's virtually no chance of being in La Nina and a small chance of being in neutral, but it's really El Nino is the most likely outcome here, as this 0.5 line here is well below the center point of our box, which is most of our probabilities there. So we're looking at ENSO, El Nino, that was declared in June. The last full month I have data for is May. So this is an ENSO neutral plot here on the left, but it's only gotten warmer. Again, we transitioned to El Nino as of 6/8, June 8th. In the Atlantic, we are seeing the mostly above average temperatures. That is much, much warmer than we were last year. The actual main development region average sea surface temperatures this year, main development region is the area in green here, from 10 degrees to 20 degrees north. That's where most of these strong hurricanes that will impact Florida will eventually have their origins. So we look at that. That average sea surface temperature is at record levels for this year. So that could have a dramatic counteracting effect on what we normally see, where El Nino takes down the storms. The sea surface temperatures in the Atlantic could ramp them up enough and creates enough storms. That's why our outlook has that kind of slight shift towards the higher end. And we didn't really go with just if you have El Nino, look at those number of named storms. If we did that, our outlook would be centered around 9 storms, but we are centered around 14 storms because we added in storms for the record warm sea surface temperatures when we did our analysis. So we kind of that colored our forecast. Our models do not show any indication that the main development region will have any kind of cooling. It's forecast to be about a ½ degree centigrade above normal, which is quite strong for the Atlantic main development region during August, September, and October. It's normally a period that has very low changes and very low variance in the sea surface temperatures. So anything that's about a half degree is a good strong amount of variance in that. So again, this on the right is about 100 model members. On the left is another 32 model members from the climate forecast system, the global model that we run at NCEP. So that's sea surface temperatures. We've all in the Pacific, sea surface temperatures in the Atlantic. Now we're starting to look at winds and wind patterns. On the chart here on the left, I am seeing some weaker trade winds, a weaker African easterly jet. We have not seen a lot of Saharan air dust outbreaks this year because of this. So we're not seeing that where we did a few last year early in the season. We saw a lot of Saharan air dust make it all the way across. We're not seeing as much of that this year due to this pattern. This pattern on the left, the wind pattern on the left, is also, it would be favorable for a bit more flow into the West African monsoon, although it is a little bit far north for that. So it's not quite perfectly set up for that. And we can see that on the right, that when I look at my total atmosphere measure of the African monsoon, it's only slightly green over Africa. We can see where other parts of the world have much stronger anomalies. And last year, 2020 and 2021, I had some very strong anomalies over Western Africa. By this time of the year, I don't have them. They're not quite as strong this year. This has picked up in June. So that could have contributed also to the strength of the waves that Tropical Storm Brett and Cindy developed from. So if this chart here were to show a lot of greens and even some blues over Western Africa in the next couple of weeks, I would say that it's trending towards more favorable for more activity. So that's one of the things we look at. The rains in Western Africa during June and July are very highly correlated with tropical cyclone activity during August, September, October, because most of your August, September, October waves or tropical storms originate from waves that move from east to west across Africa. We also, so I look at low level winds here too. This is the left is a wind plot that is about the height of the trade winds. We can see that we've had kind of a low pressure system over the eastern US a lot. We've had all that wind flow coming out of Canada, and I'm sure we've all seen stories about the smoke in Canada. So that's kind of to give you an orientation for features. We've had reduced trade winds across most of the Atlantic, where we have these kind of westerly wind vectors from west to east. Normally trade winds blow from east to west. This chart here is indicating that those trades are below normal. On the right-hand plot here, we are looking anywhere that is green or cool colors is showing above normal precipitation. So again, we're kind of seeing a mixed bag. So precipitation for the month of June over Western Africa, it's got some areas that are wet, some areas that are dry, more wet than dry, but it is not complete wetness everywhere. If I showed you this plot for 2020, I would have seen a lot more wetness, a lot more intense wetness, because 2020 was very favorable for tropical cyclone formations, both here and then that developed into the 30 storms that we had over the Atlantic. I did want to also highlight where tropical storms Brett and Cindy did form. We had a lot of low wind shear out over the main developed region of the Atlantic. The warm colors on this chart are anywhere that the wind shear is very low between the upper levels and the lower levels. Again, about 30,000 feet and about 5,000 feet, the wind difference there. So this is quite a bit of reduced wind shear over the Atlantic, and Cindy and Brett formed right in that little pocket. Then as they moved further to the north and west, they dissipated quite quickly as they ran into a lot of wind shear. We have had a lot of wind shear over the Gulf of Mexico and the extratropical Atlantic. That's not forecast to change too much. So our developments in the Gulf of Mexico in June, not as much, and probably likely to be reduced in July. So that with that wind pattern staying favorable for high wind shear over the Gulf during most of July, wouldn't expect I would expect reduced activity for July over the Gulf. For what does that look like for August or October? Again, a lot of the models had some of that high wind shear kind of pegged coming out of the Pacific and moving up across the southern tier of the US. You can see that in both of these plots in these orange kind of extensions. But they did also have some of that low wind shear out in the main development region, kind of indicated just a little bit later in the season. So that doesn't look like that's going to change too much. This is very indicative of an El Nino setup where most of the wind shear impacts are in the Western Caribbean and the Western Gulf of Mexico. So again, most of your activity will likely be coming at you from the east this year. Can't rule out a storm that would kind of come out of the Caribbean, hook across Cuba and come in the west, but again, they would have a harder time this year with these predicted wind shear patterns. If you need a takeaway graphic that you want to grab from this slide, we are expecting high activity era conditions, warm phase of our Atlantic oscillations, but El Nino competing. So again, above average sea surface temperatures, near average wind shear over, if I had to average over the Caribbean and the main development region, but the wind shear is going to be higher to the west and lower to the east. Average will be near average. Weaker easterly trade winds and only a slightly stronger West African monsoon, not something that is much, much stronger, as we saw in the past couple of years. So again, this is summarizing when most activity happens in the Atlantic. Again, most of it is after August 1st. 90% of your activity is after August 1st. And that's why we will be updating this outlook in the early parts of August. The exact date is to be worked out with public affairs and when I can get all the data I need, do all the analysis I need, and have that prepared. And the entire team can work on it and everyone has the ability to look at it. So again, our outlook is for 12 to 17 named storms, 5 to 9 hurricanes, and 1 to 4 major hurricanes. But I'm glad we are doing this briefing now, and we are taking time to prepare now and looking at what could come at us down the road, because it's much easier to prepare when it's relatively quiet rather than when you are in the cone of a National Hurricane Center forecast for a hurricane coming at you. So that's what I have, and I guess I'll open the floor for questions or whatever Ned and Joanna want.
Thank you, Matt. That was very, very good. Are there any questions? Please raise your hand, and Joanna will let you ask them. It's been very informative.
Thank you, Matthew. Yes, like Ned said, you can raise your hand. You can chat inside the webinar chat if you'd like to type your question instead. We're watching right now to see if anyone would like to submit a question.
Hey Matthew, this is Logan with the Florida Division of Emergency Management. I just wanted to say thanks for taking the time out of your busy schedule to do this briefing for our stakeholders here in Florida. I had a quick question. With the warmer water temperatures, is it possible that we see maybe an uptick in November activity?
Given the setup that we have this year, El Nino would not favor that, but you're right. If those warm sea surface temperatures are not disrupted by some activity during the season, we could see some extension of the season into November. Yes. And during high activity hours with the warm sea surface temperatures, you normally do see, more of that early season activity and late season activity that contribute to the entire season having higher numbers during these high activity eras. So yeah, that would make sense.
Thanks, Matthew.
Mm-hmm.
Anybody else, any other questions? If not, Matthew, thank you. Logan, thank you for setting this up. We appreciate it. And we look forward to your August update. Thanks all. Have a great 4th of July weekend.
Thanks, everyone.
Thank you. Bye-bye.